Hi everyone. So in this lecture we will discuss about JUnit 5 and its architecture. So here you can see JUnit 4 was released in 2006 and for over a period of 10 years it was very easy and simple framework to use. But there were few problems with JUnit 4 that slowed down its growth. So some of the problems with JUnit 4 are as follows. So here you can see that JUnit 4 came with a single jar. All JUnit 4 functionality was enclosed in a single jar file, which was used by everyone, the developers, the build tools such as Maven and Gradle, and the IDEs such as IntelliJ, Eclipse. And there were no separation of concerns as all the functionality was bundled into a single jar file. So the another problem with JUnit 4 was it had no flexible API. So as we discussed that build tools such as Gradle and Maven and the IDEs such as IntelliJ and Eclipse included support for JUnit 4. So inside their environment they provided support so that developers can easily execute the test and see the results on their environment. So here you can see the IDEs and the build tools provided a great support with JUnit 4. But as there was no flexible API, the IDEs and build tools were tightly coupled to JUnit 4. Because JUnit 4 was not designed for such tools. So these build tools and IDE, what they did, they used the internal JUnit 4 classes and even reflection to provide a support into their environment. So this was the major problem as this locked the development of JUnit. Because changing anything into JUnit jar could have break the support for the new versions. With the introduction of Java 8, the new features came out, but JUnit 4 didn't have the Java 8 features such as lambda expressions and streams. So this was also one of the problems with JUnit 4. And it didn't have the extension points. So most of the functionality was bundled into single jar file. So in order to provide the extensibility to JUnit 4, the different frameworks what they did, they used runners, rules to add features to JUnit. So using those runners and rules had its own limitations. Because as everything was bundled into a single jar file, there was no way to modularize such things. And in order to add new features, there was no way to extend JUnit 4. So these were the major problems with JUnit 4. So while designing JUnit 5, the problem associated with JUnit 4 were addressed. So it was basically divided into multiple small jars so that JUnit core was kept as simple as possible, and whatever the extra functionality the developers, IDEs and build tools wanted, they included the respective jars. So with JUnit 5, they provided a flexible API such that the developers can use the API and write the test, and a build tool and IDEs consume their respective API so that they can discover those tests and run the test. So with JUnit 5, those separation of concerns were handled. So with JUnit 5, the Java 8 features were supported such as the lambda expressions and streams. With JUnit 5, the preference was given to the extension points. So instead of using the runners rules to add new features, JUnit 5 came with an idea that we can use extension optionally packaged into different libraries, and in case we require those extensions we can include those. So this made JUnit 5 very light. Moving ahead. So as we already discussed that JUnit 5 basically made the separation of concerns. So what it actually did was, it provided an API for developers to write the test. It provided a mechanism for build tool, IDEs and any other tool to discover and execute those tests. And also it provided an API such that external tools used in their environment to run the tests and display results. So these were the concerns which JUnit 5 separated out. So now let's discuss about JUnit 5 components. So you can see JUnit 5 is majorly divided into three main components. So the three main components of JUnit 5 are JUnit Platform, JUnit Jupyter, and JUnit Vintage. So let's move ahead and discuss about these three components. So here you can see the JUnit 5 architecture. You can see the three main components as JUnit Jupyter, JUnit Vintage, and JUnit Platform. So what all this component does is, at the core of JUnit 5 there is JUnit Platform. It has basically two subcomponents, the JUnit Platform Launcher and the JUnit Platform Engine. So here you can see JUnit Platform is a core component of JUnit 5. So what does JUnit Platform does is that it provides core foundation for launching testing frameworks on JVM. So here you can see that most of the developers write the unit test. So here JUnit Jupyter is the modern way of writing the test case in JUnit 5. So you can think JUnit Jupyter tests are nothing but JUnit 5 tests. And also it has components such as JUnit Vintage, which provides support for writing tests in JUnit 3 and JUnit 4. So this component is basically used to provide the backward compatibility. So here you can see the JUnit Platform has one module such as JUnit Platform Engine. So in JUnit 5 architecture, the developer will write the test cases. So they can write test cases against the JUnit Jupyter, which is the modern way of writing the test cases, or using the JUnit Vintage, which is writing the test cases in JUnit 3 and 4. So when they will write the test cases against JUnit Jupyter, they will consume the JUnit Jupyter API. So here JUnit Jupyter API is what the developers use to write the unit test cases. So this JUnit Jupyter API has all the annotation and assertions which developer uses to write the test cases. So JUnit Platform has this JUnit Platform Engine. Now this component is used to launch different testing frameworks on JVM. So how it's done is, let's say we want to introduce JUnit Jupyter. So the JUnit Jupyter component has JUnit Jupyter Engine, which is nothing but the implementation of JUnit Platform Engine. Now this JUnit Jupyter Engine basically understands JUnit Jupyter API, and thus JUnit Jupyter API helps us in writing test cases, and JUnit Jupyter Engine knows the mechanism to discover those test cases and execute. So similarly, if you want to get support for JUnit 3 and 4, the JUnit Vintage was introduced. So this JUnit Vintage had JUnit Vintage Engine, which basically implemented JUnit Platform Engine. So the developers wrote the test cases in JUnit 3 and 4 using the JUnit 4 API, and the JUnit Vintage Engine had the mechanism to discover and run the test cases written in JUnit 4 API. So here you can see with the new JUnit 5 architecture, any other testing frameworks could integrate well with JUnit 5. So let's suppose you have your own custom API to write the unit test case. So all you need to do is you have to write your own custom engine which would implement JUnit Platform Engine. So this custom engine would have mechanism to discover and run test what you written in your custom API. So this way JUnit 5 architecture was so flexible that any other testing framework can be launched on JVM by consuming this JUnit Platform Engine. So at the core of JUnit Platform, we have this JUnit Platform Launcher. So this JUnit Platform Launcher basically launch these different testing frameworks. So how it does is, it has a service loader module, and it uses this module to discover different implementations. So each of these different implementation has their unique ID. So based on that ID, we registered a testing framework with JUnit Platform, and it uses service loader to discover those implementation. And after discovering those implementation, it also helps in orchestrating the discovery and the running of the tests. And also you can see the JUnit platform provides an API to build tools such as Maven and Gradle, the IDEs such as Eclipse and IntelliJ, and also the external consoles to use the API provided in JUnit platform to run those test cases into their environment and display the result to developers. So here with the new JUnit 5 architecture, everything was modularized and every other component had its own way to integrate with JUnit platform. So with this architecture, many of the concerns were separated out, such as developer only use the JUnit specific API to write the test cases, and the external build tools such as Maven, Gradle, and the IDEs such as Eclipse IDE and IntelliJ IDE use their own specific APIs to discover and run tests into their own environment. So friends, this was all about JUnit 5 architecture. In our upcoming lecture, we'll discuss more on this. I hope you like this video. Thanks, have a nice day.